Ja, normaal zouden we moeten live zijn. Goed, dan kunnen we beginnen. Hè. So we're already at the third lecture and the last lecture, which will discuss the learning, the work environment and shell scripting. So this is the last part. As you know, there is one lecture that you don't need to know for the exam, which is about text file manipulation and tables. So you don't need to learn this for the exam. But I think this is chapter 6 and chapter 8 you do have to know for the exam. So we will focus on this last part for today. What will we discuss? In the first case we will discuss the work environment as the terminal, the session, the environment where we work in, and how we can manipulate this terminal for us to make it easier to work in that terminal, to work in that session, to work in that environment. And this way we will have a look at how we can manipulate variables, so we can store some properties in or under a simple name. We will see how to create aliases, we will see how to create scripts, and of course this is connected to the last part, shell scripting, or also called bash scripting, where we actually try to create scripts for which we can perform complex tasks in an automated way. So this is actually what we are trying to do today. We start with variables, being that if we look at our shell environment, there are a number of variables that are used. You will also see this, for example, for PHP, so the first programming language that you'll learn, where you have variables which are actually just a name, and we can add some values to these names. These values can be properties, they can be directories, they can be colors, they can be whatever you want them to be, and we can assign them to these simple to use names. Then these names, these variables, are used by other applications, are used by yourself to do some manipulations. So it is an easy way to store some basic information. And I think we already did this for crontab. For crontab we created a variable called editor, and we assigned the path to the nano editor to that variable. In this way, if we start crontab, we actually go to the editor variable and we start that editor that we would like to use. If we do not assign the editor variable, we have the default editor, which is Vim, which is not that easy to use. We can use these variables by our scripts. So this is a first way in which we can give input to these scripts, but they are also used by other type of system applications. If we have a look at the variables, we can see that there are three different types of variables. We seem to have environmental variables, which are managed by the shell itself. So when we start a new terminal, we start a new shell, and there is some information stored in that session. These are environmental variables. Then we have some regular variables, which we create ourselves. So if we say, this variable name equals this content, this is a regular variable that we create. We can make that available for other applications to use by using the export command. What I indicate here, var, is just an example of a variable name. So we can make that available also for child processes and so on. Besides that, besides our working environment and the variables we create ourselves, we also have something called system variables. These are general variables that are available for our system. An example of this is the OS type. So you can actually have a look at the OS type that we have, and in this way we can actually see that the OS type is assigned as a system variable. We can find it there. If we want to display the content of that variable, there are different possibilities. We can try to echo the variable, echo $variable. For example, we can do this with path and we can do this with OS type. And you can try this. So I can say echo $path, and then I get all directories that are recognized by my path variable. Where do we know this path variable from? Do we know it already? Do we recognize it? I think we mentioned that when we talked about searching the file system. If you want to search for a command, if it is already installed, we use the which command. Which, for example, rm. Then I search, where can I find the command, the application rm on the file system? And this is located in user bin. And this is one of the directories that is recognized by my path variable. So only if you have a program in one of these directories, you can execute that program from everywhere within the file system. This is how Linux works. So if we want to create a new directory with executable files, and we want to execute them from everywhere, we can just add that directory to the path variable, and then it will be available from everywhere. So this is an example, path of a variable. We also have, for example, echo $OS type. And then we can see that our operating system type is Linux GNU, the GNU from GNU movement, the GNU not Unix movement. Of course, we can create our own variables. For example, if I create a variable var and I assign hello to it, then I can also echo the content of that variable. And here you see a distinction between var without the $sign and the name of a variable with the $sign. If I want to change the content of a variable, I do not need the $sign. I only use the $sign if I want to translate that, if I want to value that is within that variable. So if I say echo, I want the value in the variable and I need to use the $sign. If I remove the $sign, what will happen?
It will just echo var.
It will just echo var. So it is not translated. So if you want the content of the variable, you need to translate it and you need to indicate the $sign in front of the variable name. If I create a child process, which means I start an application from this shell, for example, I can start xterm. Is this variable available here, this var variable? Echo $sign var? No, it's empty. Because we created it here and we did not make it available in our environment. If I want to make it available, so let's close this. If I want to make it available, I can export it. Export var. Now you make it available in our environment. If I now start a child process, for example, xterm and an ampersand sign. What does the ampersand sign do? Place it in the background. And here I echo var, of course, with the $sign. Now it is available in my child process. So this is the difference between making it available for my environment or not. I can do this with export. If I want to make it available every time I start a new session, I should add this to my .bashrc. So the .bashrc is a configuration file that is read when we start a new session, and we should add it to that session if you want to execute this every time over and over again. Then we should add it to our .bashrc. And I think we also did this for the editor variable last time. There is actually another way that we can have a look at the variables, not just by echoing their content, but by actually looking at the list of environmental variables, all regular and environmental variables. And we can do this with printEnv, like print environment. And for example, have a look at home and username. How did I clear my terminal? Control L. Then it is cleared. It's still available, so if I scroll up, it's still available. But I place my prompt on top, so it's not removed. I use printEnv. It's a long list. Where can I find home? I can start scrolling, or I can search that list. And how can I search the list? Welcome. How can I search this list? Pipe, grep, and then I can search, for example, for home. So I think that we know what pipe does. Here we use the standard output of the first command as standard input for the second command. Know that there is, of course, also a usage for grep without a pipe. So you can also use grep without the pipe. But it is used a lot after a pipe, so that we say search in this output for the word home. And if I do this, I can find that there is indeed an environmental variable called home. which is specific for this environment, for this session, where I can find my home directory, the path to the home directory. I can do the same for username. And I can find my username, which is guest. I can do the same, so I tried this already, echo $OS type. This is Linux GNU. I can also try to find it in my printf. But I have no results. Why is that?
It's a system variable.
Indeed. It is a system variable, not an environmental one. And that's why I cannot find it in the printf. So system ones are not stored here. There is actually a third possibility to look at all environmental and system variables, which is the set list. And we already saw set before. Where did we see set? Where did we have a look at set? So we can just print the set list. We can search the set list, pipe grep OS type, and now I can actually find the OS type. But where did we see set? Does set -O ring a bell? It's to change some default settings. For example, the no clobber option, which allows us or does not allow us to overwrite a file. And we can change it in the other direction with the set +O. So set -O is enable it, set +O is disable it. So it's a little bit unlogical because minus is enable, plus is disable. It should be the other way around, but just remember that it's the other way around. So we can also use the set list to have a look at the different variables that are available on our system. To create these custom variables, we use the export, and of course we save them in our memory. If we start a new session, this information is lost, but we can use it in our child processes and so on. How can we solve it? Just add it to your bashrc, the invisible.bashrc. Know that there are other configuration files besides .bashrc that you can use. There's also a bash profile, there's a /etc/profile, and so on, and so on, and so on. So there are actually a lot of configuration files that are read by our terminal and read by our session, but we restrict our use to the .bashrc file. So we only manipulate this file and we don't manipulate any other files within our system. Second thing I would like to discuss with you, if we discuss the work environment, is aliases. What is an alias?
It's a shorter name for a long command.
It's a short name. It is not necessarily short. It's an easy to use name. You can choose a name that you can use to specify a more complex or a more widely used command. For example, ls-l is shortened by the command ll. And this way, if you just type ll, this is much more easy than the ls-l option, because we use that a lot. I use it all the times. But this is an alias. Can we just choose every alias that we want? Every name that we want? No, why not? Yeah, some commands are already used by the system. And that's why we need to check the name that we want to use before we assign it. How can we check this? Which? Yeah, we can use which. For example, if I do this for ll, for example, I want to create a new alias, I want to use the name ll for that, then I can check if I can actually use ll, and I can see, no, LL is short for ls minus L minus minus color equals auto. And actually, if you type in which ls, you will see that also ls is an alias for itself, is an alias for the ls minus minus color equals auto option. So these are aliases that are used a lot, but we can create our own aliases to make our life easy.
If you forget to check it and you make an alias, will it override the
Yes.
other one?
Yes, it does overwrite it. Yeah. Because these are available in our system, and if we export this or we place this into our .bashrc, this is read after the system. Thus it overwrites it. Yeah. And therefore you have to watch out if you create an alias that you first check if it already exists or not. That you be sure for that. So we can, for example, create an alias. Another option that I use a lot is the ls minus al option, to have a large overview of the different files, also the invisible files with properties on my system. I want a short version called LAL, ls minus al. I can do this with the alias command. Alias, and then first we need a name, LAL equals, and then I can provide my short name. Then I can provide my command with my options and my arguments and so on. So I call this ls minus al, and then I close my quotation marks. So alias LAL equals ls minus al. If I now type LAL, I actually get this long list with properties of all my files. So here I can actually create this long list. If I close my session and start a new terminal and type LAL, it's gone. So this is only stored within my session. And therefore, if I want this stored always, I should add this to my .bashrc. And therefore, I say nano .bashrc and here I can add it, alias LAL equals ls minus al. Watch out for the spaces. There are no spaces in front of or after the equal sign. So this is all put together. There's only one space here between the ls and the options that we use, the al options. Of course, there's also a space after the command alias. I can save this. The LAL command, Control X, save yes, file name to write, enter. And now I want to reread my file because I typed LAL, doesn't find it. How can I reread this configuration file? Source.bashrc. And if I now type LAL, it does work. So in this way, you can create your own short names. You can personalize your work environment to make it more easy for you to work in. For example, if you work a lot with archived files, you can create short names for these tar commands, tar minus xzvf commands and so on. So you can create this easy to use aliases. Sometimes we want to create some tasks with a short name to execute, but they consist of more than one command. Then we don't use alias, but we create a script for that. So scripts are actually some kind of extended version of aliases to shorten widely used, not one, but multiple commands in one term. So we can actually try this. There are some other aliases that we can actually create. For example, if we start editing our work environment, we use a lot the term nano.bashrc and source.bashrc. We use that a lot. And I see that my quotation marks are wrong. Up, this is better. It's easy to manipulate my PowerPoint presentation during the presentation. So we can create these aliases so that we can manipulate our .bashrc more easily. Let's have a look. nano.bashrc, and I will create two new aliases. Alias, and I will call the first one nb from nano.bashrc. You can choose, of course, the name. You can also call this nanob or some, yeah, you can choose. Whatever you like it to be, equals, and then we provide the command we would like to abbreviate, being nano. This is what we like to do. And then we provide our tilde sign /.bashrc. Why do I provide the in front of .bashrc? Yeah, this means that I will manipulate, I will edit the bashrc file that is located in my home directory. And of course, if I execute this in another directory, I don't want the bashrc file in that directory, I want the bashrc file in my home directory. So I specify the path to my .bashrc. Because of course you can also, in another directory, manipulate the .bashrc file, but this is not the configuration file that is read by our terminal, by our shell. The second one, I call this sb from source bashrc, is to reread that configuration file. So I say source tilde /.bashrc. So first I edit it and next I source it. And we almost always use these two commands together. These are just two examples of commands that we use a lot. If you try some exercises of the last lecture, you will see that we actually use that a lot. And therefore we create these easy to use names to actually perform these tasks. I will save this, Ctrl X, save Y, enter. And now I cannot just say SB because I first need to source it. SB doesn't work, so source.bashrc. No, I do not need to provide the path to my .bashrc because I am already in my home directory. Enter. And from now on, if I type nb, I can edit it. If I type sb, I source it. Of course, you don't have any output from that. It doesn't matter if I'm in my home directory or if I'm in another directory. I can still say nb and I open the bashrc file in my home directory. So I open the correct file. If you have other aliases that you want to use, you can use them. Of course, if I ask you something on the exam, you cannot use the aliases as an answer because an alias is very personal. And I don't know your aliases. So you actually need to give me the full-length command. Just that you don't make that mistake. So these are two useful aliases that we can actually use. If we want to create short abbreviations for commands that we use a lot, but this command exists of more than one command, so it's actually multiple commands that we want to execute, we can do this by creating scripts. So scripts are configuration files, or actually just text files containing multiple commands that we can use to perform some complex task in an easy way, in an automated way. if we run the script, we run all commands inside that script. You can create a script that is standalone, meaning that it doesn't need any input from you. It just performs a task independent of what you want to do. And also you can create scripts that need some input, so you can provide input to the script so that it does a very specific task depending on the input that you provide. If we want to write a script, and this is your first time, there are some simple steps that you need to follow. First step, create a file containing commands. Not that difficult. This will be your script. But next, and this is the second step, what we know of our Linux system, if we create a new file, this new file has some default file permissions, rights that are assigned to that file. And one of these rights that you need for a script is the executable rights. And these are not assigned to your new file. If we go to our home directory, cd, and we have a look at the list, and I have, for example, here file.txt, I can see that my file.txt doesn't have any executable permissions. So I cannot execute this file. This is of course not that easy, and therefore the second step when we create a script is giving the executable permissions to that file. This is of course also a task that is a little bit complicated, a little bit labor intensive, because we need to create a new script, create the commands, next make it executable, and then we can run it. Can we run it? Not always, because we need to place that script in a directory where the shell can find it. Or we need to provide the path to the script. So there are different possibilities here. If you want to make this script executable, we can add the directory to the path variable. We can provide the path as we run the script. We can create an alias that indicates the path to that variable, or we can create a link to that script in an executable directory. I think that is a lot for one explanation. What we will do is we will make this simple, and we will create a directory, a scripts directory, where we place all our newly created scripts. And then we make all files in that script directory recognizable by our shell. Let's try this. Do we have already a scripts directory? Scripts? No. So let's create a scripts directory in our home directory. Now watch out, if you use a capital letter in the beginning of scripts, you always need to use the capital letter. If you use lowercase letters, you always need to use lowercase letters. Just be consequent. How do we create a directory? It's not that difficult. Create directory? No, that won't work. How can we create a directory? Imkadir. Imkadir. And then we provide the name of the directory being scripts. Let's have a look. We can find the directory, the scripts directory. Of course, here we have executable rights, because if you want to open a directory, we have to execute the directory. Now we can change our position to that scripts directory. And here, in this directory, we will create all our scripts. There's also some place here in front if you have difficulties reading the screen. So from now on, yes, it's recorded. So from now on, we can place all our newly created scripts in that directory, and we just have to say to our shell that all executable scripts can be found in that directory. How can we do that? It's in a later step, but you can already have an idea. Where can we find our executable files? Indeed. Hello. So if we add the path to the scripts directory to the path variable, we can execute these scripts from everywhere, independent of our current position. And this is indeed how we're going to do this. But let's first start with our first script. It's an easy script, and it says hello world. This is something very typical for programming languages. If they give you examples, this is always hello world examples, always. You will also see this in PHP and in other languages, always hello world. Don't ask me why. It's something that we use. So let's start by creating our first script. I'm in my scripts directory. This is important. I will create my first script. I will call it, I think it's hello. You can choose how you call this. How do I create my script? Is it necessary to first touch the file? So you can create a new file with touch, and then I can provide a file name, for example, hello world dot, and here I provide sh.
If you just do nano and
it will also work. So I can choose, or I create it, and then I say nano hello world, or I remove the first command and I just say nano hello world, and it will also create this file called hello world.sh. I provide the sh extension. Is this necessary? No, this is not necessary. Then why do I do it?
It's to easily recognize files.
Yeah, to recognize it. This is actually good practice. It's not necessary, but if we assign the .sh from shell script to the name of the script, we recognize this as a shell script. So this is just for us to easily recognize these scripts. Do you need to do this? No. But I do it as of good practice. I have my first script. I can just type commands, one command per row. But there is something special again here, and this is the first line. And the first line starts with a hash bang. Hash bang. A hashtag and an exclamation point. And then after the hash bang, we provide the path to the program that needs to execute this script. Which program will execute this script? Bash. So our shell, or born again shell bash, will need to execute the script. And that's why we say /bin/bash. So we provide the path to the program that needs to execute the commands that follow after the first line. And now there's something special here. This line starts with a hash, followed by a bang. And how do we call this line? It's not the hash bang line, but the shebang line. I think you will remember this. So the shebang line starts with the hash bang. We can add some comments, and this is very typical. These start with a hashtag. So if you add a hashtag in front of the line, this actually indicates that this is a comment, so this will not be interpreted by our bash. We can add comments here. Of course, this is not useful, this is just some text, but you can add information for this script in the comments. Also within our script, if we have a long script, we can add comments to indicate here is some code that is doing this type of work, here is some other code, here is some other code, and so on. So we can use these comments to clarify the uses of this script. Also, for example, if we create a script that needs some arguments, you can say as a first comment, this script needs 2 arguments, so that you know the next time that you use the script, I need to provide 2 arguments. This can be useful. And then we start with some commands. And for example, I can use the echo command. What does echo do? It echoes some output in my terminal. And what will I echo? Hello world. Can I also use variables to change the content of what I echo? Yes. Echo, hello, did we see username? So we can also use this. We can provide variables, and then it will translate my username, and it will say, hello, guest, in my case. I'll save this. So I have my shebang line, I have a comment, I have some commands. I will save this. Yes, enter. Now I can find this, hello world.sh, but I don't have the X permissions. How can I add the X permissions to my file? Gemod, skmod. Who will have the X permissions? You can add them for all users, but you can also be a more private type and say only I need the executable permissions. So then you say U plus X. And of course, don't forget to provide the file name. If I look with LL, you can see that this file is now green and is an executable file. This means that I can execute this. Oh. No. Indeed. I haven't added the path to this directory to the path variable. This is in the next step. What can I do? I can just provide the path in my terminal. Say this is now here. And now I can execute this. So by providing /, the path, it's a relative path, but it is a path, I can actually execute it in my terminal. If I don't provide the path, it thinks it is a command, but it doesn't recognize the command.
Is it al zonder dat ik die punt aan die slash ervoor zet?
But you probably already assigned scripts to the path variable. Is the scripts directory in this? Yeah, it's not in my path variable.
Het stond erin, maar ik heb het er daarna terug uitgevoerd. Nu staat hij wat gekomen.
Voilà. Problem solved. Can I execute this from somewhere else? No. Only if I provide the path to the script. Then I can execute it from somewhere else. Of course, this is not useful. And that's where we're going to the next stage. So we need to make it executable. We can say U plus X, A plus X, or we can use the numerical view to provide the X permissions, and then we can run it. But we want to make it available from everywhere, and that's why we are going to add this directory, the scripts directory, to my path variable. So if I add the path to this directory, to the path variable, I can execute this from everywhere. What is the path to this variable? /home/guest/scripts. So if I say export path equals, do I just say /home/guest/scripts? Do not execute this, by the way. Will this work? But I will not be able to execute any other commands anymore. Only the commands or the applications that are in this scripts directory, because I overwrite it. I don't want to overwrite it, I want to append it. How can I append this? Let's have a look at the path variable. Here we can see a path separated by a colon, a next path separated by a colon, and so on. So if I use the current content, add a colon and add my new path, I just append my new path to the path variable. It's a lot of path, I know. They should have called it another name, but it's path. So this means if I say export path variable equals the current content and I can translate this from $path. So now it places the current value inside the path variable, and then I append the directory called /home/guest/scripts. I select it and I use my middle mouse button to paste it, so that I don't have to type it again. If I export this, echo path, I can find my new path in the path variable. And now I can execute without the / hello-world.sh. I can go to my home directory, hello-world.sh. I can go to the root, hello-world.sh. So independent of my current position on the file system, I can execute all scripts in the scripts directory because I added the path to that directory to the path variable. Is that clear? Yes. Thank you. So every script that I create in that directory can be executed from everywhere within my file system just by calling its name. Of course, I should have checked if hello-world.sh was already in use. Yes, I can find it in my scripts directory. I'll start a new terminal. hello-world.sh, it's gone. So I exported it as an environmental variable, but in my current session. If I want this always, I need to add this to my .bashrc. How can I modify my .bashrc? NB. So not nano.bashrc, just NB. Because I created this alias. If you did not create this alias, just say nano.bashrc. But this does the same as NB, because if I say which NB, you can see that this is actually an alias for nano.bashrc. So NB, let's go down, export, and don't make any mistakes in your syntax. So be very precise with your commands. Export, path equals $, path, colon, /home, /guest, /scripts. So don't make any mistakes here. If you make a mistake and you screw up your path variable, you will not be able to execute any command anymore in your terminal. It will do nothing. You will type something and it will say, don't know what it is. How can you solve this problem? My .bashrc is a very personal file, which means that this is only for the guest user. If I log into the system, for example as root, I can go to the .bashrc of my guest user and I can modify that .bashrc. I can remove the incorrect line and then I can log in as guest again. So by logging in as root user, I can correct the mistake. This is just a hint, if you would make a mistake, that you can solve it yourself. Of course, if you only do what was asked, you will not have these kind of problems. But if you try to experiment, it is possible that you have some problems. Also, a suggestion for you, if you have worked a lot on your Unix system, on your Linux system, and it is working fine, try to create a clone of your virtual machine. If you screw it up the day before the exam, it is no problem because you have the clone. But if you don't have a clone and you screw it up the day before the exam, good luck. So create a clone, just for your own sake. So now I save this. Yes. I source it. So sb source.bashrc. And now hello world.sh. And as you can see, I start typing hello. I press the tab key. I have to double L, and it auto completes my command because it recognizes the command in my terminal from everywhere. Is that clear? So this was our first script, the hello world script. Of course, we can also create other types of script. Now for this first part, it was just a static script, meaning it does always the same thing, independent of where we are, what we want. It just says, hello world, hello guests. But sometimes you want to actually give some information to the script that the script can use to work with, so that it can perform a specific task. How can we do this? We can do this by using variables, and we can do this by using parameters. So we can provide information for the script. And there are actually 3 different types of ways in which you can provide this type of information. We can define these variables outside the script and then use them in the script. For example, if I say export pingu equals tux, I can use the value of pingu in my script because I exported it to my environment, and then I can use this in my script. It's the same, for example, for the editor variable that we created. We can also use the value of that editor variable in our script. So this is possible. What else can we do besides just assigning it and using it in our script is to ask for that variable value in an interactive way. In this way, we actually have some communication with our script. Our script will ask us a question, we provide a value, and then this value can be used. Of course, the question that is asked by the script, you provide yourself. So if you don't say, echo, give me a value, your script will not ask for a value. So you need to provide this question yourself. So this is a second option. And a third option is actually what we do when we use default commands, so these standard commands in Linux, is you provide arguments. You say rm and the file name. You can also do this with scripts. You can use the script name, and then provide an argument, and this argument is used by the script. So this is a third possibility of how we can provide input to a script. Let's start with the interactive way. So the fact that we can use... Where does the music come from? The fact that we can create variables in our environment, we can export them and we can use them into our script is of course very clear. But besides that, we can actually ask for this in an interactive way, and we can do this with the read command. After the read command, we provide the name of the variable we want to use, and by entering the text, we will actually assign the value to that name, to that variable. Next, we can use it in the rest of our script. Let's try this. So let's try to create a script. Where do I create my script? In the scripts directory. So remember, always create your scripts in that directory, so that they are already recognized by your shell. We create a new script. Nano, how will I call this script? I will call this hello user.sh. It doesn't look that good. Hello underscore user.sh. Ja?
Ja, moet doen eigenlijk. Dat is eigenlijk als ik iets rap typ, alleen hem ter eerste dingen, dan komt er zo 3 keer op die letter. Geen idee hoe dat komt.
Dat gaat de gevoeligheid zijn van je toetsenbord blijkbaar.
Ja, dat is echt ambetant, dus eigenlijk... Zie?
Ah ja. Geen idee.
Ik kan daar niks aan doen.
Nee. Ik vrees ervoor.
Ja, dat is wel...
Oké, Google. dat het zou kunnen komen. Misschien dat er iemand een oplossing heeft, maar ik vrees ervoor.
Ja.
Dan gaat dat echt iets aan de communicatie van je toetsenbord met Linux, dat hij dat zo veel typt.
Dat is ambetant.
Ja, ik kan me dat inbeelden. En heb je het ook met een extern toetsenbord?
Ja, dat gaat wel een probleem.
Ja, wie weet dat het daarmee opgelost is. Het is maar een kleintje om een extra toetsenbord mee te nemen. Het ziet er misschien grappig uit, maar als het werkt, is het wel handig. Dan kan je nog een tweede scherm meebrengen. So let's create a new script called hello user.sh. We first provide our shebang line. If you make a mistake in the shebang line, for example, you type something wrong, you will get an error message when you try to execute the script, and the error message will say bad interpreter. So if you see the error message bad interpreter, this means that you made a mistake in your shebang line. It's not that useful. I provide a first comment saying this is an interactive script. Then I echo something. So as indicated, if you want your script to ask you a question, you need to ask the question yourself. It will not just ask you something. So I say echo, what is your name? Your name, question mark. And then we can read your name. Read, and you can choose the variable, so the name of the variable that you want to use here. For example, you can use answer as a variable name. You can also use user as a variable name, and so on. So read answer, and now I can use this variable to actually print some very specific output. Echo, welcome, $, answer. So here we will assign our value. We will actually ask for input on the command line. And here we will print the value that was assigned to that variable. I'll save this, Ctrl X, save yes, enter. I'll make it executable. Maybe it is a good idea to create an alias for this. Hello underscore user.sh. And now I can execute this. What is your name? Jasper. Welcome, Jasper. We can make the output a little bit better, because here we try to have some interaction with our script. We try to make a conversation, but of course I can see my previous commands. This is not that nice, so let's change that a little bit. Let's, for example, say here clear, and also here clear. Save, yes, answer, and now I execute this, and you can see your terminal is emptied. I get this question, I provide my name, I press enter, and I just have welcome Jasper and the prompt back. So this is a possibility, just to have some kind of interface with your script. Just something simple that we can do. So in this way we can use values, we can provide values, we can use these values, and so on. So this is a possibility that we have here. Besides asking for them in an interactive way, we can also provide them on the comment line. So instead of providing my name when my script asks for the name, I can just add it as a first argument to my script on the command line. We call this positional parameters. And there are a lot of positional parameters, 1, 2, 3, 4, and so on. And their number is determined by the position on the command line. The first argument that you have is $1. The second one is assigned to $2. The third one to $3, and so on. There is an extra positional parameter which is called $0, and this is the name of the script. So in this way we can also use the name of the script as a variable in our script. Let's try this. Let's create a script. Nano. How will I call this? Positional parameters.sh. And I'm already I think it's labor intensive to provide the shebang line every time again, all over again. No? But I already had 4 hours of Linux before this lecture, so it's 6 hours of Linux on one day. So my shebang line comment, and here you can actually provide a useful comment. Please, you don't have to be that nice to yourself. Please provide 2 arguments on the command line. So that you know that you need to provide 2 arguments on the command line. And then you can start echo the name of this script equals $0. So the name of the script is assigned to $0. And then I can echo parameter 1 is $1 and 2 is $2. Save. Yes, enter. Let's make it executable. And now we can execute this, but don't forget to provide 2 arguments. arg1, arg2. The name of the script is /home/guest/script/positional parameters.sh. Parameter 1 is arg1 and 2 is arg2. So here you can see this is my $0, the name of the script. This is $1, this is $2. So in this way I can actually use the arguments that I provide with my command, with my script, which I use as a command, to actually use that input in my script. I will add something extra. For example, what if I want to quote the output? For example, parameter 1 is parameter 1 and 2 is parameter 2. How can I quote this? Can I just add the, for example, double quotes? What will happen? It will just look the same as before. So if you use double quotes, this just says for the echo command to translate what is in between these double quotes, but treat it as one value. We can also quote everything. If I don't want to translate these double quotes, because this is done automatically by the echo command, what can I do? I can escape them. And how can we escape something? With a backslash. So I can do backslash double quote. This means that it will not be translated by my terminal. And that we will actually print the double quotes. This is the same. For example, if I add and 3 is, and then I escape my $, what will happen? Of course, now I need to provide 3 arguments. Let's try this. arg1, arg2, arg3, and what will happen? I just print $3. So I escaped the $, it is not translated, and I just print the $. So this is something that you can use when you use characters that are translated by your shell. We can escape them with a backslash. Then it is not translated and just printed. What if I want to print a backslash? Where will I place this? And backslash, backslash. Will this work? Control X, save, enter, backslash. Yes, so you can escape a backslash with a backslash. This is just some extra information for you, if you would like to use that. Sometimes it is nice to have something quoted, then you can escape the quotes by using a backslash. There is actually a script that I would like to make, and it is a script that allows me to automatically create a new one, provide already the shebang line, and make it already executable. So instead of saying nano script name, providing the shebang line, typing my commands, saving it, making it executable, and so on, I want this happen at once, so that I can just start typing my commands that I need for the script. Can I create a script that does this? Yes. How will I call the script? You can choose. I will call this magic. You can call this magic, you can call this magic.sh. So you can choose. Let's call this magic.sh. How does the script look like? Of course, I need a shebang line. Always. And now I know what does the script do? It automatically creates an executable script with name $1, so that I know that my first argument for the script will be the name of the file I create. The first thing I want to do is add my shebang line to this file, to this newly created script. And how can I add the shebang line to this script? Echo, good. Now I will use single quotes and echo the shebang line, which is hashtag exclamation point /bin/bash, and I'll echo this to a file. And how is this file called? So the script I will use to create a new script, and the script already has the shebang line and is already executable. So I can just echo the shebang line to that new file. Of course, where do I want this file? In the scripts directory. So instead of echoing it to $1, I will echo it to ~scripts/$1. So now I have a file called $1 in my scripts directory. Of course, $1 is translated into the first argument that I provide. in my scripts directory, and now I want to make it executable. Commod u plus x, and I provide the file name, so tilde up, to make this file executable. Now I have a file containing a shebang line. I have made it executable. What do I want to do next? Is start editing it. I want to start adding commands to my new script. Thus I say nano, and again I provide the name and the path of that file. Control X, save, yes, enter. This one is not yet executable, but after I make this executable and I use the magic script to create new scripts, they will always be executable. Commod u plus x, magic.sh. Now it is executable, and now I can start creating new scripts. For example, and instead of using nano, I type magic.sh, and I provide the file name. How will my first script look like? Test.sh. I enter. You can see that I have a file called /home/guest/script/test.sh. I already have my shebang line, so I don't have to type it again. And I can add commands. I save it. Save, yes, enter. I'll have a look at the permissions, and it is already executable, so I can directly execute it. Did I need to create a script? No. But this lecture is called the work environment, and we manipulate the work environment to make our life easy, and that's why I created a script. So that I don't have to type that shebang line every time again. What happens if you say magic.sh with first argument magic.sh? Then it's gone. Then we overwrite our file with the shebang line and we lose our file. So don't do that. Okay? So this is how we can use arguments on the command line. We can use these positional parameters. We can try to make some manipulations with them and so on. Now, why do we use these quotes? As indicated, we use a backslash to escape the next character. For example, if we want to add quotation marks. What else can we do? We can use single quotes, and then we know that if we place some text with variables and so on between single quotes, we will not interpret this text. So everything that is between single quotes will be printed as it is. So we will not translate this. If we say $username, we will not translate $username, we will just print $username. So nothing is translated. If we use double quotes, this is the same, but we do actually translate some things. We translate a $, we translate exclamation points, and so on and so on. So some characters are actually translated within our double quotes. What is the difference between using double quotes and not using double quotes? We can see multiple words as one value. So if we have something that a value that is consisting of multiple terms separated by, for example, a space, then our terminal thinks these are multiple arguments, but by using double quotes we can actually see this as one argument. So this is considered as a whole. And there's just some example here. What will happen if we execute the script? What will it print? The value of What will it print? Echo, the value of something equals the value of double quotes. What will that do? Something equals something. Echo the value of what will it say? Dollar sign value. So it will also print a dollar sign. So the value of dollar sign value equals something. And here the value of dollar sign value equals something. So in the first two cases we will actually translate value into something, and here we don't translate it because we escape the dollar sign. We don't know that this is a variable. That's why we just print dollar sign value. And also here, because we place it between single quotation marks, we actually escape the value of the dollar sign. So why use quotes? Because we have problem with spaces. We want to provide one argument, but this one argument consists of multiple words separated by spaces, and that's why we provide this as quoted values. So this is only one argument that we can provide. Something that we already used. Sometimes we want to manipulate the input. We want to use a value at the moment that we actually call a certain command, and we can do this with, we call this command substitution. So we can translate a command, we can translate a value at a certain position and already use the value at that position as some kind of argument or as some kind of input. We already saw this when we wanted to create, for example, a file that uses today's date. We already saw this. We can, for example, use string specification, the date plus %a. So normally, if we use the date command, what does the date command do? Print the date and time of my system. If I specify plus %big A, I get a very specific notation. And these are all indicated in the man page of the date command. So I can specify the output of the date command by providing a string specification. There are also other string specifications, plus %y, %m, %d, so big Y, small m, small d, and this will provide us with 2018 October 24. So in this way we can specify the output. What?
Ik zit nog op 15 oktober.
In this way we can specify the output. What if I want to create a file that uses this information automatically? How can I create a file? Touch. And now I want actually the output of this command to be used as file name. I cannot just say date plus %y, %m, %d. What will happen? I created two new files, one called date and one called plus %y, %m, %d. No, I just want the translation of that command used at that moment. And this is what we call command substitution, is that we actually execute the command on the position of the command line and use the output as input for or as an argument for the next command. How can we do this? We can say touch, then provide the command that we want. I'm doing this in an unlogical order, plus %m, %d, but saying that we need to translate this date command at that position. And we can do this with backsticks. So these backsticks are these diagonal single quotes. And you can find them on, yeah, it's different for every keyboard. So search for them. So you can do this in this way. These are these diagonal, so these are not the straight quotation marks, but the diagonal quotation marks. For me, they are next to the micro sign. So the micro on the keyboard, but this can be somewhere else, especially if you have a QWERTY keyboard. I think it's on the upper left corner under the escape character for QWERTY. I think, maybe. I'm not sure. So you have these, we call this backsticks, and if we provide something between backsticks, we will translate the date command on that position and use the output as argument for the touch command. So if I execute this, LL, I did create a file called 2018-1024. Because these backsticks are sometimes difficult to interpret, we can also do this in another way. For example, let me change this to %A, then I will print Wednesday. This was indicated before. Instead of using these backsticks, I can also use a $ and place everything between brackets. This is the same, which is a little bit more easy. Again, date with a string specification will be executed here. The output will be used as name for the touch command. And I have a file called Wednesday. This is what we call command substitution, and sometimes it is easy to use because we want automatically assign some value to a word, to a variable, to a file, to something else, and so on. So we want to execute these commands automatically. And that's why we can use command substitution. Of course, I want to remove these files, so rm and I have deleted them. So with the tab key, you can just complete the names of your files. Because they all have different types of names, you cannot use the asterisk to autocomplete our file names. If you would have file 1, 2, 3, 4, we can say file and a star, and that would automatically remove all files starting with the term file. But we cannot do this here. As indicated here, this is just an example that you can use. What will be the result? If we say today equals and we use this string, what will we echo? Wednesday. So we will echo Wednesday. What will we echo here? No. Date plus %A, because here we used single quotation mark because we didn't use the diagonal ones. So this is the difference. If we do it here, we will again echo Wednesday. So this is the difference that we have here. Next, we'll have a look at how that we can, at a way that we can modify our input, and we can do this with substitution operators, with pattern matching operations, or we can just do calculations. So we can use our terminal as a calculator. So we can assign values to variables and just subtract them, count them up, and so on. So we can use them as a calculator. A first one is actually very useful when we create strings, and these are the substitution operators. Normally these substitution operators, and you can see 3 of them, are not used with the echo. So they are just used at the current position. You should think like this is command substitution. So a $ and something between brackets. Of course, these are not round brackets, but curly brackets. So it's a little bit different here. But actually, this is executed at that position. If we echo this, this will echo the content of the variable. But we do something special here. And here we have 3 different cases. Here we actually check if the variable already has a value. And in this example, I did not assign anything to variable, so I don't have a value. What will happen? I provide a colon and a minus sign, and then I provide a value. If there is no value already for this variable, it will just return or receive the value word. It's like you say variable equals word. But it checks if it has a variable. If it hasn't got a variable, it uses word as the value for that variable. The second one is a little bit different. You see, we don't just use the word word, but we also assign it. And this is why we use the equal then sign. So we use the value, but we also export it so that we can use it in our environment. The third one is if we don't have a value, we actually create an error message. And this way we can say, oh, wait, you did not provide an argument. For example. So if you need an argument for a script, we can actually include this type of message to check if there is a value. If there is no value, we can give an error message, or we can specify a default value with the other ones. Let's try this. I'll do this with echo so that I can print the content of the variable if it is not assigned. So I use my $sign, I use my curly brackets, and then I need a variable. Let's, for example, use editor. Because editor is already assigned in my .bash rc. Now I can provide my colon, minus sign, and I can provide a value. I'll do it easy. I'll use the value. What happens? Editor is already assigned, /user/bin/nano. So normally I should create the value /user/bin/nano. So in this case, my variable has already got a value, so I can use the value. What if my variable doesn't have a value? For example, the variable editor2 does not exist. I just created it, or did not create it. Then I can see that if I echo editor2, I get the value because I just assigned it. If I now do echo $editor2, editor2 is empty. So I just use the value, but I don't actually export the value. I can try the same with the equal sign. Of course, this will give us /user/bin/nano. What if I do this for editor2? I get value. And if I now echo $editor2, you will see that the value is actually exported for that variable. So this is the difference with the minus sign. Here we just provide the value, but we don't export the value. So it's only used once. Now we can use it every time again. Echo, curly brackets, editor, colon, question mark. That's a lot of work. And then I can provide an error message. There is no value. I think I did something wrong. What happened? It's because I used the exclamation points. So you cannot use the exclamation points, or you need to escape them, or you need to use single quotes. So user bin nano. If I have another one, now I of course need to use editor3 because in my previous command with the equal then sign I assigned it. I will get an error message from bash saying editor3 there is no value. So in this way, if you create a script, you can provide these personal specific error messages for the problem that you have. Is it clear, the difference between the minus sign, the equal then sign, and the question mark? Yeah? So these are useful things when we want to check our input. So we have a script, the script needs some input, but you should check if the script does provide you this input. If the user that uses the script does provide you this input. If it doesn't provide you this input, for example, with the error message, the script is stopped. So if you have this as a first check, you have a mistake, you don't have a value, then your script will be stopped. You don't execute the rest of your script, so you don't make any mistakes. So you can actually try to use this. Next, besides substitution operators, we can also use pattern matching operators. Maybe it is important to note that these slides are from the last chapter, so bash scripting, and this is open book exam. So you don't need to know this by heart. You can just look it up, but know where to find it. Pattern matching operators, for example, I have a variable. This variable contains a lot of forward slashes, contains some values, and I will, for example, use pattern matching to search from left to right and to remove some parts of my pattern. For example, and you can use this when you locate something, you have a path, /home, /guest, /script, and so on. And you can, for example, remove the path and just give us the file name. We can do this with pattern matching. How does this work? Again, we use the $, the curly bracket, and then we provide the variable for which we will do pattern matching. This is var. And then we use a hashtag. If we use a hashtag, we search from left to right in our variable for everything that is provided here in red. So what do I want to search for is a /, everything in between, and again a /. So I just try to find something with 2 /, with something in between these 2 /. So the star is my wildcard. If I provide one hashtag, I will search for the shortest match. And I search from left to right. So this means I try to match. I have my first /, I have my second one. This is my shortest match. What is the longest match? This forward, everything. And what do you do if you provide 1 or 2 hashtags? You remove the thing you match. Can we try this? So I will make a variable var equals /1 /2 /3 /4 and so on. And now I will try to match. So echo, I again use my curly brackets. I will try to match something in the var variable, and I use my hashtag to search for the shortest match. What do I want to match? /*/. Oh, it's wrong. /*match. And I remove /1/. I think that you already see that this can be useful. For example, if I want to create a script that prints the name of the script. This is done with $0, but this provides us also the path to the script. If I want to remove the path, I can use this to remove the path from the script name. If I do this with double hashtag, I will remove the longest match, which is everything. Very similar to the hashtag, I also have the %sign. The %sign is the same as the hashtag, but we don't search from left to right, but we search from right to left. It's just the other way around. So I start at the right and I search to the left. For example, if I have a variable /user/bin/info/ .hello.tk and I search for the match .star. If I search from right to left, shortest match is my .tk. What is my longest match? My .hello.tk is my longest match. I'll just provide something because I forgot what it was. So /user/bin/hello.file.tk. I use percent to search from right to left. And what do I search for? A dot and something between after that. So I actually try to match a suffix, and I want to remove that suffix. 1% sign, shortest match. 2% signs, longest match. So if I want to remove the suffix and I want to remove the part, what can I do? In one command, here I remove the suffix, and if I want to remove the part, can I say no? I cannot do this. That's not possible. In a script, I can assign the first substitution to a variable and then apply the second substitution to the same variable. This is possible. But I cannot substitute in a substitution. What else can we do? Is replacement. So until now we just removed parts from left to right or from right to left, but I can also substitute. I can substitute or replace 1 by 4 from left to right. Replace the first match with 1 slash, all matches with a double slash. Here the syntax is already a little bit more difficult. What if I want to replace the dot file with dot file name? How does my command look like? Do I need an extra slash? No. This way I can replace the file with file name. All replacements. So 1 slash, double slash. What else can we do is calculations. And here we start to introduce loop structures. What type of calculations can we do? We can plus, minus, divide, product, modulus. Do you know modulus? No? What is modulus? Let's try this. Let's create a script. Or can we just? No. Would be too easy. Let's create a script. Calculation calculation.sh, and let's do a calculation. I'll start with the first number, and this first number equals 10. And next I will take the modulus of this 10. How can I do this? The modulus 3 of 10. You can see, if we want to assign this, we need to translate it there and use double brackets. So if I want to create a new number, number 2 equals $, and R %3. What if I divide 10 by 3? What happens? I have 3 comma blah 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 blah. What does the modulus do? If we divide 10 times 3, we have 3. 3 times 3 equals 9. And what is the rest? 1. So it's actually a rest division. It takes the, how do you say it, integer of your division, the rounded version of your division, multiplies this by what you divide by, and then takes the rest. So we divide 10 times 3 by 3 is 3 comma and so on. If we just take 3, so we round this, 3 times 3 equals 9. What is the rest between 10 and 9? 1. So we have 1 extra. Now we can echo the result. Echo $ number 2. And let's have a look at this calculation. One. It is actually 1. We can also try to create this loop structure. We can just copy that if you like that. So let's create a new script. I'll call this loop.sh. I'll paste my sequence here. But I'll remove the shebang line because I already have one. Counter equals 1. Here we have a while loop. While this is true, do, done. Which means that we execute everything between the do and the done. While this test equals true. As the word true has a value true always, it will always be true. So what will happen? I think it's okra. I have a counter. I have a counter equals 1. I start my while loop. I'll add 1 to my counter. My counter equals 2. Then I echo my counter equals 2. I go to done. I return to the while. While is still true. I do, and so on. So in this way I will have a loop. You can save this, Ctrl X, save yes, enter, and I can execute this. And what will happen? Because while is always true. How can we stop this? Ctrl C. And this way we can stop this. So this is just an example. Here we do a calculation. So we add something to our counter. Our counter is specified here. But of course, because we have an infinite while loop that is always true, we do not test something, we will always keep counting and counting and counting. Of course, we don't want this situation because this is an infinite loop. We will never stop this loop. And therefore, we can actually add a test condition. How can we test something? We can test actually everything that we want. You just need to know the syntax for that. But we get an exit status when we test something. So with the test command, you get an exit status if it is correct or if it is not correct. This exit status was also indicated before. If you perform an exercise, for example, pipe grep file, I have no output. I can have a look at the exit status by echoing $? And I see I have an exit status 1. And in comparison with what we always know, 1 is good, 0 is not good, this is actually the other way around. If we have an exit status of 0, this means that everything is correct. If we have an exit status that is higher than 0, we have a problem. An exit status of 1 means cannot match. If we can match this, for example, if I try to grab, I have some file called loop.sh, then I can actually match something. If I now look at my exit status, I have an exit status 0, meaning success. We did match something. We did have a good output for this command. We can use these exit statuses when we test something in a loop structure or in a conditional testing. If this is correct, then you perform this task. Else, if this is correct, then you perform this task. So we can use these exit statuses with the test command to perform actually some kind of conditional statement. How can we do this? For example, test -f / etc. / password. What will this do? Let's have a look at the exit status, 0. What does that mean? Test -f. Man test. If you want to know how to test something, you should have a look at the man page of test. There is a very, very, very big list of possible tests that you can perform. Then we search for the -f. How can we search the man page? /, and then we can start our search term, -f, enter, and you can see the -f option is used, file exists and is a regular file. So with the test -f / etc. / password, I test if the password file is an actual file and is a regular file. So if it exists and if it is a regular file. If we do this, for example, test -f password, this file does not exist, and my exit status equals 1. So this is different. So here I do actually test something and I get output dependent on that test. As an alternative, and especially when you compare something, we don't use the test -f or the test command itself, but we place something between square brackets, as indicated here. If you, for example, have two positional parameters, $1, $2, and you want to test if these two parameters are the same, you can place them between square brackets and place the equal sign in between. If this is correct, we can do something. If it is not correct, we can do something else. We can say echo, they are the same, or echo, they are not the same. Watch out. I do not just place them between square brackets, but I also provide a space. So it's square bracket, space, string equals string, space, and then I close it again. So there is a space after the opening square bracket and before the closing square bracket. Just that you don't make any syntax mistakes there. So you need to provide these spaces. And then you can see that there are different kinds of loop structures, especially here. So what we have here between the square brackets is our test situation. You can test something. You can also test it, for example, by saying square brackets -f and the file name. We can do this. So instead of saying test -f, we can place the minus f and the file name between square brackets. This is possible. You have if-then structures. An if statement ends with phi. It's the other way around. If blah 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 blah, then blah 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 blah, then blah blah blah, phi. Then we know that the if is stopped. And we can test something. If this is correct, then we perform this task and we can stop. If it is not correct, we don't perform this task. Next one, if this is correct, then we perform this task. Else, which means if it is not correct, we perform this task. So we can provide a second task for the other condition. What else can we do? We can test multiple conditions. If this is correct, then we perform this. But if I want to test the second option, I can use the elif. Not the else if, but the elif. So in Linux, this is elif. Elif a second test condition, then perform this task. If none of these conditions are correct, then we perform the last one. This first one has a shorter form. Here. We test something. If this is correct, then we execute this command. So if we use a double ampersand sign, we perform something if it is correct. This is a one-line command to test something and to execute something. The double pipe is the same, but if it is not correct. So if, for example, I test this is a file, if it is not a file, I can say this is not a file. So here it's the other way around. This is actually what we do with the else. So the thing that we provide after the else, we can provide after the double pipe. Next, we can have a for loop. For e in some kind of array, we do an iteration over the different values of that array. We do something and we done it. Then we close it again. So do, done, if, phi, and so on. Let's give you some examples, and I think this is the most important part for you, is that you have a working script for every example that we have. For an if then, for an if then elif, you create a script that does work. On the exam, if I ask you something, you can just copy the code, don't write it again. This is too labor intensive. Just copy the code from a working script to your script and adjust the code. This is the most important part. If you learn to program, you don't write the script yourself. You copy the script and you adjust the code. But you copy from a working script. So not from something that gives you an error. Let's try the first one. If $nr minus GT 100, then blah, 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 and so on. So I'll copy from the echo until the phi. How we will call the script? We will call this if then elif then else phi. So magic if then elif then else phi dot sh. Because in this way I know that I can find an if then elif then else phi condition in the script. You can call it whatever you want to call it. What happens here? I ask you something, give me a number, then I read that number, the number is assigned to an error, I clear my terminal, and then I start my first if statement. For the if statement, I provide the condition between square brackets. I provide my value, don't forget the spaces after and before the square bracket. I provide my value, which I provide in an interactive way, and then I ask a test question. And what do I test? GT, what does that stand for? Yeah? Greater than. So I test if my number is greater than 100, then I echo and R exceeds 100. I can have a second condition. If, you can read this as else if, I test something new, my number is lower than, less than 10, I echo, my number is smaller than 10. In all other conditions, I echo, my number is between 10 and 100. And I think that there's something wrong with my quotation marks. Yeah, there's something wrong with my quotation marks. So here you can see that the first quotation marks are correct, but the last ones are not. So we can also use these bash shortcut keys in the terminal. Control E places my cursor at the end, and I can replace the quotation marks, and also here replace the quotation marks by the correct double quotation marks. I can save this, Control X. Dat moet ja zijn, hè.
En dan heel kwaad als er zo'n groen boxje op het einde blijft staan. Dan is het...
Nee. Dat zijn vaak spaties en zo.
Ja.
Oké. So, save modified buffer, yes. Enter, and then I can execute this if, then elif, then else v. Enter, give me a number, 120. 120 exceeds 100. I can try the same. 5 is smaller than 10. I can try the same. 52 is between 10 and 100. So this is my if structure. The next one that I have, these are just examples, is a script with arguments. And in here we'll have a look at different variables that we can use in our script. This is a for loop that we will use. I will not copy the shebang line. So I'll create a new script. I will call the script for loop.sh, and I'll copy my, it seems correct. What happens when we create a script with arguments, we can actually save these arguments in different types of variables. We have the $* variable, the $hashtag variable, and the $@ variable. And we can actually have a look at what this variable does. Does it contain one value or multiple values, and so on. I will only have a look at the first and the last one, because the second one doesn't have multiple values. Here we will iterate for e in this group of values, do something, echo the value. If I replace the e with, for example, an r, for an r, then I can also replace here the e with an r. So this is how this works. I will add something extra here. I will add at the end of my echo a asterisk to indicate that this is the loop for the asterisk, and I will add at the end of this one an @ sign to indicate that this is the echo for the $@. I'll save this. Yes. Enter. And let's have a look at my for loop. But it's a script with arguments, so you need to provide arguments. arg1, arg2, arg3, and so on. And what happens? If I use, I cannot use the asterisk. If I use $asterisk, I return arg1, arg2, arg3, which actually looks the same as if I would print the $@. This looks the same. The $hashtag just provides me with the number of arguments. So if I have 3 arguments, our $hashtag will give me or will return the value 3. But how are these stored in these variables? If we have a look at the first one, we just print it all in once. So instead of having a loop, this is actually just one value, and $* contains all arguments in one string. So this is printed all at once, and then I have my star being all files that are in my directory. If I use the @ and iterate over the @ I have every value separately. So for example, if I have a file containing multiple arguments, but I don't know how many arguments I have, I cannot just say $1, $2, $3, and so on, because I don't know how many I have. I can use the loop over the $@. And in this way, I can actually separate each argument. If I have 2 arguments, I will loop twice. If I have 5 arguments, I will loop 5 times. Of course, the order of the arguments and the value of these arguments should not be that important, just to loop over the different arguments that are provided in your script. So here we can use the $@. Next loop structure, and we're almost there, is the case structure. And especially here, don't remember how to create these case structures, just copy the code. What can we do? Let's have a look. Let's create a new script called case.sh. Case.sh. I'll copy the content of my script. What is going to happen here? I ask you a question, you provide me with an answer, and then I will have a look at that answer. And I will test. If this answer equals yes or yay, I will echo nice. If your answer equals no, I will echo too bad. For all other answers, I will say echo what do you mean? So here I can actually try different possibilities with the case. Of course, I can replace the case structure with if. If, elif, then, this is the same. You can see that you can provide one value, but you can also have multiple values. And if we have multiple values, we separate them with a pipe. Then we test both values. You can answer yes or you can answer yay. This is the same. And something special, why do we stop our case structure with ASAC? We turn that around. So it's the same for if phi, case ASAC. It's case backwards. Control X, yes, enter. Case.sh. Do I need to provide arguments? No, because it's interactive. I use the read command. Are you all right? No. Too bad. Can try another one. Was it yes? Nice. And I think I had another one. Yep. Was it yep? No. Of yay. 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 Also nice. And if I just don't know, what do you mean? So in this way you can test different types of things. Of course the tests that you can perform here are equal then. My value must be one of these specified values. With the if structure I can test other things. I can test if something is a file, I can test the file size, I can test whatever I want. Bigger than, the same file type, and so on. So if is much more elaborate than here, where we just match the content of these values, if the value is actually the same as the other one. The while loop we did already encounter. And there's this last one that I want to give to you, something informative, and this is how you can read lines of a file. This is something special, but it's used a lot. So if you want to process some files, we want to iterate over every line of a file. And we want to do some manipulation of the different lines. And therefore we need to read that file. How can we read the file? We can just provide the file name. So let's start with magic.sh, read lines.sh, and I'll copy this here. I added a counter to provide you with lines. So I have a counter. While I read line, so I create a new variable called line. I can call this whatever I want. And every line that I read from my file will be assigned to this variable. So I can use it by using the $line. But how do I add my file to the while loop? In this way. When I finish my while loop with done, I add, how do we call this? The smaller than sign. An input redirection. And my argument is the first argument should be a file name. So I add my file as input redirection in my while loop. And this is very strange that I place this at the end of my while loop. It's just something you need to know. If I place an input redirection after done with my file name, I can read over every line of my file. I also have a counter here, and let's try this. Save, yes, read lines. Just remember, this needs an argument because we use $1. If you test this without $1, this won't work. Which file can I use? I have a file called if then elif then else v. And I can read the different lines of this file. Line 1 is my shebang line. Line 2 is my echo. Line 3, I read my number, then I clear my terminal, then I have my first if statement, then I perform something, then I have my second if statement, then I perform something else, and if that is not correct, I perform the last thing. So in this way I can actually read different lines of my file. Again, you don't have to invent the warm water all over again, just copy the code. I have provided you on Lego during this lecture, the PowerPoint presentation of that lecture of bash scripting. There are a lot of exercises. You will see, try to create this script, try to create this script, and I provided you with an overview of the different scripts and solutions of these exercises from that presentation, so that you have some kind of group of scripts that actually do work, should be able to work. On the exam, if I ask you to create a script and your script does not work, don't panic. I look inside the script for different structures that you use. If I see a problem, I will not penalize you with a 0 score for the whole script. I just will penalize you for a 0 score for that part of the script. So also if your script does not work, you can have a good score. So I actually look at the different parts of the script and not at does it work or doesn't it work. Of course, this is a first indication on your script. So I can use it as a fast screening, but I will also look at the content of your script. Okay? That was it for today. You have still some time until the exam, so it's only the second week after the fall holiday, so it's only in a couple of weeks, so you have some time to study. If you have some questions, you can mail me, but I think it is better if you ask them on the discussions on the forum, so that also other students see these kinds of questions and you get the opportunity to learn from each other. If you know the answer to a question, you can also solve it. So you have the possibility to solve each other's questions. So have a look at these discussions. Sometimes you can have the same question as another student. Okay? Good luck.